Okay. Hi, everyone, and thank you for joining our call today. We hope not to spend too much time on discussing everything that we have to discuss, but still the enough amount of time would be dedicated to the issues that we need to work with now. Maxim, as you already have the slides here, probably just go ahead with them.
Okay, so do you see the slides?
Yeah.
Today I'd like to start with giving an update on the RGB status and what is released, what is planned to be released, what would happen out of the next release. And also I would like to, in the second part of the presentation, to cover quite an important part of RGB system called strict types. And because this is the part which was released last week, and this is a part which will be very important in developing RGB smart contracts. I hope that deserves a dedicated section of the presentation. So let's start with the roadmap. Right now, RGB, right before the new year, we've got version 0.9 released. It was called Release Candidate 1, but since for some time there were no issues discovered, so not all crates have a full release. They have just version 0.9 release candidate 1, but in over some time, like by Monday, they all will be updated to version 0.9. And 0.9 was a maintenance version, the second maintenance version, which happened after the last summer release of RGB protocol. However, much more important things and much more interesting things for RGB are going to happen, and they are going to happen in what we call version 0.10. Over the last half of the year, since the release of the original protocol, the community in different discussions came to conclusion that there are certain things which has to be improved in RGB in order to unlock ability for independent developers to do a different complex smart contracts things like DAO, support more expressive language, do interesting cross-contract communications. And since the summer, we were designing this feature set, and actually that would be the feature set which will get into the version 0.10. And here on this slide, I structured the interdependencies between different libraries that represent the RGB as a working system. The most important part is the heart of RGB. We call it consensus part of the story, and this consensus part of the story are data which we commit to, and these commitments are going into Bitcoin blockchain inside tab return thing. Not like ordinal NFTs now, in different way, fortunately. This consensus thing is the part that has to be very carefully crafted and not changed after people start really using it. So some of the changes, many of the changes which will go to 0.10 release will address the consensus layer. And unlike previous releases, 0.9, 0.8, which didn't touch the consensus layer, this new release will touch it. And later on, I will explain what it means, what consequences it have, and how we can avoid happening this in the future. But after certain discussion, we decided to do this consensus breaking changes with the new release because they unlock really important functionality for RGB. And the other part is the part which helps people to use RGB in practice, like to integrate into wallets and exchanges. Sorry, I'm missing one arrow here. I will add it straight away. Otherwise, it doesn't make a lot of sense. Well, this one and this one. And these are optional components. So with the arrow, the white arrows, I'm showing the dependencies between different components. And with these dotted arrows, I'm showing optional dependencies. For instance, the Lightning libraries shown in the bottom right corner, these ones, it is an optional dependency. Of course, if wallet doesn't work with the Lightning network, it doesn't need to depend on the Lightning. Or this wallet library, which we also do, is optional because you can use BDK or other wallet library. While these dependencies, shown with the white arrows, they are required dependencies. So starting from wallets probably and exchanges, wallets depend on the RGB standard library, which is not a part of the consensus, but which is a library that makes it handy to use low-level consensus level libraries inside the applications like wallets. And also there is an RGB node library, which depends on the standard library. And with this version 0.10, RGB node will be used by only exchanges. Before that, it was required to run RGB node inside the wallet. Now, with the new version, we remove that requirement, so the wallets will become lighter and easier to manage. The whole validation will still happen, but the validation will move from RGB node down to the RGB standard library. And the consensus part of the system consists of 5 main components. I structure them into different groups. It's not layers in strict sense, it's just 2 groups. The one is external dependencies, which are used not just by RGB, but they may be used by projects which have now nothing related to Bitcoin or any crypto at all. And these 2 projects are a virtual machine called Alluvium. So you might think about Alluvium as a form of VASM-like virtual machine, but it's not like VASM. It's a virtual machine which differs in fact that it uses a functional approach to running the code. And we had a lot of discussions last year about how it works. Today, we don't have a lot of time to discuss it. And with this new version, there is literally nothing happened in that virtual machine, so it remains there and it works as before. But what happens is also that we introduce this new thing which called strict types. And this is a functional type system, data type system, which tightly works with Alluvium and which allows to do formal verification and formal structuring of types inside, which are used inside RGB and client-side validation. So basically, this system will be used to do the programming of RGB smart contracts together with a contractum language, which will be compiled to run on Alluvium. And this strict type system is the thing, one of the main features that we introduced in version 0.10. And we will have a full second part of the presentation dedicated to the explaining what it is and how it works. And the next component, the client-side validation library, which depends on the strict types. I'm doing the overview, and later on I will be explaining what happens with each of these components. So it's just, this slide is more to explain the interrelations between components and what components are there. And the client-side validation library does the ground level implementation of features which are common for client-side validation approach. And it can work not just for Bitcoin, it can work for different other systems, like it can work for Proof Marshall and other approaches, which are not part of RGB, but also there are people who are working on them, like Peter Todd. It is being used by Bitcoin Core Library, which actually is an application of client-side validation to Bitcoin and to Bitcoin blockchain specifically. And finally, on top of that, we have RGB Core Library, which does the smart contracting, combining the virtual machine with the client-side validation and Bitcoin all together into one streamlined system. And today we already have a release for strict types, which has happened last week. And today we released a client-side validation library with version 0.10. And we expect to release the rest of these libraries, the remaining 3 libraries of the consensus level, by the beginning of next week, with the other part, non-consensus part, being released to version 0.10 during February until the end of the month. So that's an overview. Now let's move to explaining what specific changes has happened to RGB. And I will structure these changes according to this schema, according to the blocks in this schema. So let's start with the strict types. There is a dedicated website for strict types. You can also go to GitHub organization, because there is a number of repositories related to strict types. The project is quite large and it deserves an organization on its own. Strict types is about formal verification. It is basically a new language, and this language will be part of the contractual language, which will be used for writing RGB contracts. And this new language shares functional properties like Haskell and Idris. It actually looks like Haskell, and it has the same functional qualities as Haskell itself. But on the other hand, unlike Haskell, the language is close to bare metal like Rust. It allows to directly see the bytes and simplifies the working with a bare metal. So this is why this language is required, because as of today, there is no pure functional language that allows to do many low-level manipulations with the same efficiency as Rust itself. And the more important, this language defining data types is automatically generated right from the Rust code. So you have an option to write data type description in this new language, but you can instead write Rust code and use it and auto-generate the new language representation, the strict types representation, and as well as compile it and use it inside RGB and Alluvion virtual machine. Another important property of the strict types is that it does generation of the specification about the type system and how it behaves in automatic fashion. Again, if you write a type description in Rust, it automatically produces the specification of how the type is serialized, deserialized, and verified. And you don't need to write the spec, you just copy that part into the spec itself. So it reduces the amount of errors which you can do when you describe the way your code works, and it actually bridges the gap between the implementation and specification. From now on, they are equivalent and can be transformed into each other in a provable way. And that's why it is able to prove that the actual implementation of certain data types follows the spec. So that's why it was quite important to move the RGB on this new type system, because in this way we can make sure that we are fully specify how RGB consensus layer work, and we also would be able to detect any consensus breaking changes in the future, because the strict type system, by creating a formal specification of the data type, it's also able to detect that the new version, the new release has a different formal specification, detect in which parts this formal specification differs, and even generate automatic migrations if needed. So this solves one of the main problems with the consensus level protocols like Bitcoin have. When you do a new release of Bitcoin Core, there is no way how you can prove that it doesn't break a previous consensus rules. You can't do that in a formal analytical way. It's just a matter of sufficient number of eyes looking into it, but still there is always a risk that some bug was not spotted. Here, this is done automatically with a formal analysis, and you just run a program, and program says that the new version doesn't break any consensus rules of the previous protocol version, or it does break the consensus rule in this specific part, and you can fix it or revert it. So that's a quite important thing, and it's really unfortunate that it wasn't there when Bitcoin was created. Otherwise, we would have much less problems. So how does it look? It looks like this. You have a certain type, for instance, in Rust. We will go with the workflow when we start defining type in Rust code. You do, for instance, an enum. Let's invent some quite advanced enum with associated data. It has 3 variants, like index with associated 8-bit integer. Another variant is fields, having 2 subfields, name and value, and also there is some third option which doesn't have any associated data. So it's quite elaborated Rust structure. And to do the strict encoding, to apply strict encoding, the only thing you have to do is to add these derive macros. You have to derive the strict type definition. A strip dump trait allows you to produce dump values for testing. And strict encode and strict decode that does the binary or text serialization in deterministic fashion. Also, you have to provide information in case of enum. You have to say that this variance of the enum would be neatly tagged with a certain value based on their order. So if you change the order of the fields, the semantic ID of this type would also change. And when you have this, you can actually do with a single line of Rust code in test or in binary, you can print out the strict type definition, which looks like this. It's much less verbose than in Rust. It defines the data type of the same name, SOP. And it says about these three fields. Index fields are three from here, three variants. And index has associated data. Fields have actually two associated data, which are named in the same way like here. And there is a third variant which doesn't have associated data. So this is how the strict type code looks like. And also this code or Rust compiles into this binary form. And this binary form represents a strict type library. Right now it has just a single type, but it may have more types. And this library has a unique ID and a checksum represented with a three-word mnemonic, such that if when you change anything here, you will get a different ID, but you would also have a different checksum, and checksum is much easier to visually verify than this non-human readable ID string. And this is just a base encoding of the binary compiled data, which can be useful if you send the library through the messenger or email, or you need to show it on slide like here. But of course, the compiled version has a binary form. So in other words, strict types is a protocol buffers, but made for functional programming. And if you go to the strict types website, which I have here, you will see that there is even a diagram putting that the strict encoding, it's a previous version of the strict types, occupies a space in the among other languages which haven't been occupied before, which is both functional and close to the bare metal. So that's the strict types. To summarize, the strict types works with a generalized abstract data types. It's something that comes from type theory and based on category theory. Each of the types is confined. That's how it also differs from Haskell. So it's not just a bare metal layer language, but it also always specifies the minimum and maximum size of each data type, or minimum maximum size of elements in array, map, set, such that it can't happen that you have a type which have a maximum size of 32 bits on one platforms and 64 bits on other platforms, like it works today with Rust and other languages. And it also, unlike in Haskell, where you may have arbitrary precision integers, not predicting how they would behave in memory representation on different platforms. Here, you always know what are potential size bounds for each instance of each data type. That also unlocks ability to run the smart contracts with the strict types on low-end hardware, like hardware wallets, and predict that it can run on the hardware, because you always, without running the program, you can analytically compute at compile time their resource requirements, the program resource requirements. Also, in strict types, each type is able to describe itself, which adds a reflection. You know that Rust lacks reflection, and sometimes it's really handy. And when you do this with derivation with Rust, you actually add reflection to a data type written in Rust. It also that each data type able to describe its memory layout. and you can compare data types by their memory layout, which is very important when you need, for instance, to migrate data from previous version to the new version. You can use strict types outside of smart contracts, but for instance, for storing the data in your software on disk, and you did a version upgrade, you can detect how you change, did you change actually the serialization format, and if you change the serialization format because of this memory layout analysis, you can see how you can do an automatic migration from previous versions to the new version. And finally, what also differs strict types from all existing systems, that each type here has a semantic ID. A semantic ID is unique 256-bit integer, and this integer is basically commitment to the memory layout plus semantic information of the type. So for instance, if you change a single name of the field or order of the field or name of the type itself, it will change the semantic type ID, even if memory layout is not changed. And why we have that is because, for instance, let's take as an example, a normal integer, 8-bit integer. It could be a number of items in an array. It can be some counter. It can be a byte, or it can be a set of bit flags. All these data types are different, semantically different data types, but they share the same memory layout, 8 bits, 1 byte in memory. So that's the case where semantic ID really comes to play in the cases like this. And I will actually show right away the slide from the second part where I demonstrate that here we have this example from before. And when we change just a name of a single field, it was indexed and became indexed. It changes the ID, checksum, and the serialization of the data type, as you see. So that allows to do the semantic versioning, while these both types would have the same memory layout. Okay, that's all for strict types. We will pay more attention how they work in the second part of the presentation, but now let's move to other components which resemble the RGB consensus level. And the second one is the client-side validation, which is actually released today in version 0.10, beta 1, but it's beta 1 because we need to make sure that the other components work with that well. And with this release, what we did is we migrated the whole type system to this new strict type system. And it resulted in reduction of the code base on, like we have 12,000 lines of code less. 12,000 less lines of Rust code, just because we migrated to the new strict type system. So it makes the code much easier to audit. It makes code formally analyzable. And again, the system is able to serialize its own specification and describe the way it works with all the data types. Also, we have updated the whole commitment workflow basing on this strict type system, such that, for instance, if you have a collections, they got or was merkleized automatically, and we also streamlined and automatically enforcing commitment rules. So we define a set of rules how the data has to be committed to be put into the final hash which goes into blockchain. And we define these rules once, and they are automatically enforced for all data types based on their strict type representation, such that we don't need to manually code this over and over again. And that's how we got this reduction of the number of lines of the code. Okay, other than strict types, the client-side validation has also got rid of Rust Bitcoin and Rust miniscript dependencies. It was a hard decision, but the reason of this decision was the fact that Rust miniscript actually comes as a legacy. We are not using it anymore, so it wasn't needed. But Rust Bitcoin was used. However, we used just a very few types out of Rust Bitcoin library, very simple few types. And for that types, we depend on the whole Rust Bitcoin, which have a drawback of the breaking releases. Like this library is still quite far from 0.10 release, meaning that with each release it breaks API. And each time the Rust Bitcoin is released, we have to do the release of all crates in the consensus level, which is undesirable because we would like to move towards the ossification and don't release new versions of consensus level crates unless there are some bug fixes which need to be done. And the fact that we getting rid of Rust Bitcoin dependency allows us to do that. So we just moved the types we are using into the consensus level. And we also actually had to re-implement them because there is a second problem associated with Rust Bitcoin, which became apparent with a famous or infamous hack happening last autumn on Lightning Network, where a guy named, what was his name? Burak, he published a special crafted transaction which literally killed all Lightning nodes, but it also crashed all Rust Bitcoin based nodes. And the reason was because Rust Bitcoin makes assumption about Bitcoin consensus level constraints, and it doesn't correct assumptions, different from Bitcoin Core. And to avoid such situations, it was decided to not to depend on Rust Bitcoin library and to do the reimplementations of the structures we need for RGB without any assumption about Bitcoin level consensus rules. And it was very helpful that we have this strict type system such that we can always control what we assume and what we do not assume. Finally, with all these changes, we plan to have a full support for WASM target of compilation. And that is also important to get RGB working in the browser extensions, RGB wallets working in the browser extensions. Okay, the next thing is RGB Core library, the last component of consensus level, because Alluvium is not changing this release. And what happens in Rust Core is that, first of all, we introduce a thing which we call global state. A contract would have a global state now. We had some analog of global state before, which was called metadata, but there were no clear global rules how different conflicts between metadata provided by different branches of history can resolve. With the new version 0.10, we introduced the rules for resolving consensus level global state. And that would happen, that unlocks a lot of applications on top of RGB. Like, for instance, if you need to do a synthetic assets, algorithmical stable coins, or you need to read certain forms of contract state which belongs to the contract as a whole, that actually the feature which will allow to do that. Also, because of the introduction of strict types, now in smart contract, you can store and work with arbitrary complex and composable data types, all of which are described with a strict type system. And they can be part of their own state and global state. So not like before, when you had just a primitive types, like integer, string, and so on. You can have arbitrary structures or structures inside structures, enums. Everything that you can have in Rust actually can compile into RGB in the way that I just demonstrate. The next thing is that we're fully moving to Alluvium. There was some hard-coded validation rules previously, which we used before we were sure that Alluvium works fine. So now we're removing all hard-coded validation rules, and all validation for smart contracts will be done with Alluvium through the Alluvium. We also significantly reduced the number of dependencies, as I described, mainly because we're moving Rust, Bitcoin, and Miniscript, but also we removed many other dependencies, including the dependency on the green implementation of bulletproofs, because we think it's wrong to be dependent on other cryptocurrencies, things which can't be controlled, and actually it wasn't audited, and one of Bulletproof's creator, Andrew Postra, specified that when he analyzed the code, was asked to analyze the code, he found that it differs from the actual specification of the Bulletproof. So That's why I decided to move out of it. And green bulletproofs were not also compatible with WASM, which allows us to finally get the library, RGB library compiled for the Rust. With all these changes, we began the process of ossification. So all the new releases, which will be happening after 0.10, will be bugfix release only and must not contain any new features. And we planned to do that before last summer, but unfortunately it happened not to be possible, primarily because we were depending on Rust, Bitcoin, and Miniscript, but also because all this functionality which I just described was really important to have in RGB while it's not being widely used yet. So we decided to do another one breaking release, but stop here and start the process of the ossification. And now I'd like to pay some attention to the question of these consensus breaking changes and non-consensus breaking changes in RGB and in client-side validation in general, because they work really different from the Bitcoin world. RGB is not blockchain, client-side validation is not blockchain, and actually the truth is that on RGB there are no forks. You can't say that it's a soft fork for RGB or hard fork. We used this terminology before, but this terminology is incorrect and it actually leads to invalid conclusions. So it's better to replace this terminology with a better one. So in RGB there are no forks because there is no chain which you can split with a fork. There is nothing to fork. The whole RGB history is directly acyclic graph, not organized into a chain of blocks. And this graph's not kept somewhere, it's kept by each owner. And this graph is always different between different owners. So there is always a chain split between all of the owners of RGB. So the fork is meaningless. The term fork is meaningless. As well, there couldn't be a network splits like in RGB or Lightning Network, since there is no P2P network in RGB. So these all things are not applying to RGB. But still, there might be some protocol changes and potential asset losses caused by these protocol changes. So there is something, but this something clearly not fork, not chain split, not a network split. So what is it? Well, there are two main types of RGB consensus changes. The first one is when something which was invalid before now becomes valid. And this is something that is called in blockchain world hard fork, but for RGB, it's actually quite opposite to hard fork. Because when you do something invalid and it becomes valid with a new release, existing owners are not affected because owners can't own something that was invalid. Nobody can own a state or has a state that was invalid according to the consensus rules. So nobody is affected, unlike in Bitcoin where everybody is affected. New beneficiaries may be affected in this case because if they run a previous version of software, they may not not be able to validate the transfer. But in this case, the transfer is not cancelled. The funds are not lost. It's just that they have to update their wallet and get this transfer happening once again, having the client-side data sent to them once again, and then they will pass. So actually, in RGB, the only reasonable way of introducing any new features is this type of change. And I propose to call them fast forward, like in Git, where you just fast forward to the new functionality, to the new code branch, and without affecting the stuff that you already have. And unlike the second option, where when something was valid before and with a new release it becomes invalid. And in Bitcoin, it's called soft fork and it's good, but in RGB, it is really bad and it has quite opposite results as in Bitcoin. Because when something was valid and becomes invalid, that means that existing owners lose assets. If the moment they update the wallet, they lose their assets and probably they wouldn't be, well, they can recover them, but they need to roll back to the previous version. And in fact, any change that makes something valid invalid is a new protocol. It's not RGB anymore. It's an RGB of different sort. Probably it shouldn't be even called RGB. And the only thing how you can do a migration with such thing is that the issuers of all assets and contracts need to reissue the assets on the new protocol, and all users have to upgrade running 2 versions of the wallets, which is really impossible to coordinate when the RGB is used in large. So that's the new 2 terms. Fast forward changes and pushback changes, and the first are acceptable and the second must be avoided at any cost. The version that we are doing, 0.10, will be a pushback. So this would be the thing that we shouldn't do anymore in the future, and we are doing it only because we have this ability today. There is not a lot of users of RGB. There are no real asset issued, and the funny assets that were issued before, they can be easily upgradable because we know all the users by names. But this wouldn't be able to do. We wouldn't be able to do that after, and we hope that major bugs wouldn't be discovered. And in this case, after several months, we just renamed version 0.10 into RGB version 1. And any future features which will be added to RGB must be fast forward only. We still can't exclude that a pushback may happen in the future because of some critical bug fix which will be discovered later. And in that case, the asset issuers would have to provide the users with the upgrade path. And yeah, it would be quite a trouble then. And for the current pushback which happens, the owners of the RGB assets which were issued last year, again, they have no real value, it's just memorable assets. They would be provided with the wallets that they are using, a way how they can upgrade to new assets issued with the new protocol. Okay, so that's where we are with RGB consensus level. Is there anything that can be added to RGB in the future? Of course, not as pushbacks, not as breaking changes, but as new nice features. Well, right now we do not plan that, but maybe by the late 2023, we will do a fast forward, bringing more algorithm codes, support for reflection of Bitcoin blockchain data, such that smart contracts can read arbitrary Bitcoin blockchain-based data and take decisions based on this data, and also some of codes enabling cross-contract interaction and access of states of one contract through the others. But before doing that, we will do a careful evaluation of the risks which may be brought with these changes. So it's not a plan, it's just a possibility that at a certain point there would be a fast forward bringing this functionality. Also, later we will do an update with the bulletproofs when there would be a bulletproofs library able to compile for WASM, and we expect that it would be a library which is Blockstream now working on. And also maybe in some distant future, many years from now, we will do zero knowledge based roll-ups over the historical data, which will grow quite large up to that point. So that kind of things which may happen to RGB protocol, and they may happen as a fast forwards, not pushbacks. So these upgrades to protocol are possible. Okay, so we finished with the contract, with the consensus level. So let's now cover what will happen to RGB standard library and RGB node and what functionality it unlocks for the wallet developers. So with this release, after when we will complete version 0.10 for consensus libraries, later during the February, we will work on the same release for standard library and the node. And first thing that it will bring to the mobile wallets, the possibility not to run quite heavy multi-threaded RGB node, and they will be able to use just a standard library to do all the validation locally. So it's not a light client. It's not that they will be talking to some server. No. They will still need to talk to Bitcoin Core as before, but it's not that they will require to be talking to RGB node on the server side. No, they will be doing local validation the same way as before, but just without running dedicated node, which manages all the threads by itself and storage. And it's quite heavy duty to mobile application. It also uses zero message queue internally, which adds a C library dependencies, which are very heavy for mobile. So that's all removed, and now you just use library and it does the validation, and you manage threads the way you want by yourself. Also, this standard library will provide unified JSON-based API for all contract types and interfaces. So before, the wallet developers had a need to develop for each contract type, like a fungible asset, or NFT, or identity, or DAO, a dedicated library and a dedicated integration, and do a new release. And actually, it was required to do release of RGB node, of wallet, of integration libraries. Now everything is standardized, and thankfully for the strict types, which are also serializable into JSON format, the wallet developers, to add a support to a new contract, they can develop a contract by themselves. They don't need to recompile even the wallet. They don't need to get a new RGB node version. They just need to import the strict type definition of the contract interface into the wallet, and that's it. Also, in the same way, you would be able to add custom schema and contracts without changes to RGB node or to the bot itself. Another thing that we unlock ability to back up RGB client-side validated data called stash during the runtime when the application is running, because with RGB node before it wasn't possible. Now it would be possible for the wallet developers. We are simplifying invoicing. Right now, invoice format is quite complex, binary, and large. We found a way how we can make it much lighter and simpler. And we introduced shorter, simpler, and safer contract IDs in new encoding format. The one that is used in strict types, I was showing you, this easily readable and checkable checksums, and shorter strings comparing to back32. Those who are interested why not back32 but bait58, you can go to this explanation, GitHub, and read it. This is this new encoding format. And here is explanation why and how it's better than other encodings and why we switched to it. Okay, and finally, we're adding ability for asset issuers and contract developers to sign their assets with additional metadata, which are not part of RGB consensus, but which allow to check the identity of the asset or contract issuer or developer, and it's based on SSH or GPG signatures. Maybe in future it will be enhanced with RGB-based identity management, but it would come later, not in this version. So that's the overview of all these changes. This is the tree of how these changes are depending on each other, and how we progress with releasing this thing. These two things are already released. These things are pending release by the start of the next week. And after that, for the rest of the February, we will be working on the layer above this line. So that's where we are today. And the final slide of this part of the talk is what would happen next after this RGB 0.10 release in February. And hopefully, we hope that it will become RGB version 1. Well, we will be working on updating wallet and exchange integration libraries. We will be releasing main types of RGB contract interfaces for wallets, like as standards and recommendations how you can do fungible assets, NFTs, identity, decentralized naming system, and even DAO. So probably it would be happening during March and April. In parallel, as a priority, even before this thing happens, we will work on RGB Lightning integration to get RGB assets transferable through the Lightning. And so there we will move our efforts on completing our LNP nodes and the stuff like that. And for the remaining part of the year, we will be working on getting DEX functionality into Lightning together with RGB and completing the tool chain to write the RGB contracts with the contractual language. So that's everything about the roadmap. And maybe before we will pay a bit more attention to strict types and how they can be used, let's have a questions regarding this part first.
I have a question about terminology, my favorite topic. You say that the fast forward is used in Git, right? For something similar. I was not...
Git, yes, it's a term from Git.
While pushback is just an extrapolation from that analogy, correct?
It's just that, like I was looking for thesaurus in English and trying to find that word which fits the meaning. Maybe so it's not the best.
Fast forward, what it is exactly, if you can repeat it?
Well, in English, fast forward means to move to a new version, literally.
Yeah.
And in Git, it means that if you have a branch, local branch, and the remote branch is ahead of your branch, and there is no conflicts between two branches, it's just several commits ahead, you fast forward to the tip of the branch. Okay. So you basically move forward up to the latest changes. So that's what actually happens with the RGB and client-side validation. So a new version of protocol is released, you're using previous wallet, you update the wallet, and you fast forward to the new protocol version. Kind of that thing.
Okay, thanks.
But maybe somebody can give a better term, better English word.
Also, I never realized until this very moment that the situation with backward compatibility is exactly the opposite of global consensus. We knew since a while they were different, but I never realized they could be presented as the very other way around as for problems of backward compatibility. Interesting.
Yeah, and that's why actually when I also understood that, because I understood that through the practice, I decided that we need to change the wording, because calling this thing hard fork is really incorrect, and it gives a misinterpretation of what actually happens.
Makes sense. I wonder if the inversion can extend to something like in minor censorship in Bitcoin can create evil soft fork. In this case, probably in this case it's not symmetric. Okay, nothing.
Yeah, and hard forks still can happen to RGB, and soft forks can happen to RGB, but on Bitcoin. So if Bitcoin is hard fork, the hard fork happens to RGB as well. So we can't use the same. Yeah. So we need to avoid use of this term probably for RGB specific stuff. Any other questions? We had a discussion before about version 0.9 because it was released at the end of the year as a release candidate 1. For some time there were no bugs or changes discovered. So since the release take a lot of time, like it took 3 days to do all the release, we have about 50 crates involved in RGB as of today. So for those who are interested, you can go to github.com LNPBP. There is a repository called LNPBP nodes here, and there is a wiki page which describes this release process. So this is the list of repositories that has to be released for the new version. It's more than 50, and what we started doing is just reducing the number of that repositories and number of cross dependencies, and we are have very good progress with that in version 0.10. So the release, I decided not to do the full release because we have release candidate 1 and it saves a lot of time not to do it all over again. But later we have some fixes. So as of today, all RGB consensus layer is released for version 0.9 with the joint efforts and help from community and Zoya specifically. RGB standard library is also released, but RGB node remains in release candidate 1, and the reason for that is because to come from the standard library to node, we need to release another 20 crates related to Storm and Lightning Network, and it will take time. So the plan is to have RGB node release to the 0.9 to happen on Monday, and before that time, it's still possible to use the latest 0.9 version of the all other crates together with RGB node if you can apply the patch to the cargo toml file. So that's the plan. It's a parallel thing that happens in parallel with RGB version 0.10, and the final release will happen anyway this Monday. And after that, it will be maintained for some time, but as a lower priority comparing to the work on the new version. Okay, any other changes before we move to the last part? We actually covered most of it, so it will be much faster, like something 15 minutes of that sort. Shall I move, or maybe somebody wants to discuss something? Okay, let's complete the story about the strict types. I already covered this slide. I don't know, Giacomo, was you present when I was talking? Because like one of the things I would like to hear is your opinion.
I think at least once, yes. I don't know if you covered it more than once. But
no, once.
Okay, yes, I was.
So how this thing looks, here is several examples. All types, data types using the generalized abstract data type theory are either product types or sum types. Basically, why they call product types, because when you add fields to the product type, the possible number of variants multiplies. For instance, you are using one field, 8-bit field, you have 256 possible values. If you use two fields of 8-bit data, you would have 65,000. So 225 multiplied by 225. And 256, sorry, multiplied by 256. That's why it's a product type. When you add fields to the product type, you multiply the number of possible states of the state type. And the product types are in Rust, which exist, are tuples and structs. They differ that the tuples, they have unnamed fields, while structs, they have names attached to the field. The same is in strict type system and in contractual language. Basically, contractual language is a superset of strict types, but today we are talking only about strict types, which is basically a data type system, how you define data types in contractual. And all data types declared with the same keyword called data, then follows the name of the type, two dots, and the fields. And these fields can be named, and then it matches the struct, or unnamed, and then it's basically a tuple. So these types are cross-compiling into each other. If you have one, you will get, and compile it into the strict types, you will get this description. And for sum types and sum types, because basically they don't multiply in a number of states, when you add a variance, so in product types, the fields called fields, here they're called variants. When you add another variant, you add another variant. It's not multiplied. So if you have n with 3 values and you add 4 value, the possible number of states has changed from 3 to 4. So you add another type. That's why they're called sum types. And there are two types of sum types, enums and unions. But unfortunately, unions are reserved for different meaning in C and Rust, so that's why its proper name is associated enums. So enums and associated enums, and the difference is that enums are just pure sum type, while associated enum is a sum type which may have some sort of associated data, either embedded struct or another enum or something of that sort. And here how they are defined in Rust. For instance, here we have quite elaborated type associated with associated data of different sort, and they all compile into strict encoding. Actually, in Rust, there is no type. You can't define a type in Rust which wouldn't compile into strict type system. And that's an example of compilation. And actually, for instance, here you have this option value, and here it's just encoded with a question mark up to the value. So you see now how much more laconic the strict type system is comparing to the original Rust definition. So you can, maybe some would prefer it, maybe some would prefer to Rust the Rust version and then compile it to the either human readable or binary form. And as I said, if you change anything in the type, for instance, even by a typo, you're working on your code, you accidentally press OK, it gets into commit, reviewers haven't seen it, but the checks when you compile the text of the change says that the new version have a different semantic typing. So coming back to the question of pushbacks and these forks, in terms of strict types, the fast forwards is when the semantic type becomes different, but memory layout stays compatible, basically the same. So for instance, you renamed the field, it is a fast forward. So there is no consensus breaking changes happens. It just could be that you have changed the meaning of the data. For instance, before it was an index of some sort, and now it is an hashed data because they are indexed and you take the first byte. So this change in name actually usually means change in meaning, and that's why we commit to the naming as well. But more, you have a different ID. So each type have two IDs. One is semantic ID and the other is memory layout ID. So in this case, we change semantic ID, but memory layout ID stays the same. But when we change, for instance, here from 8 to 16-bit number, then the memory layout will change. You will add another byte into the type, and that will change the memory layout ID, and it would mean the pushback in terms of RGB. So both of these types of changes may be detected by the compiler, and they will be detected by the compiler such that when we do a new release, we can check that there is no memory layout breaking changes, actually no pushbacks for RGB, and only fast forwards, which we know about and we clearly intending to add them, happens with the new release. So that's why the work on strict types was quite large, and there was a lot of concerns, should we do that or not, but I think that it was a good decision to do them because we ended up with a very strong provable qualities which even Bitcoin itself lacks. And from the tool chain point of view, you write some Rust type, you build it, and compiler build in-memory representation of abstract syntax for strict types, which can be converted, serialized into this textual representation, the source code. The files with the source code will have an extension of st. So this is the source code, which you compile from the Rust code and serialize from the Rust code. And this source code or the abstract syntax tree taken from Rust can be translated or compiled into a binary form, which is strict type library. And the binary form is this one, this compiled version, and it's a base 64 encoding, but you can just write a binary file. And that's the part which we have already seen. And I would like to show you how this work looks not for test type, but for real world example. And that is a very interesting example because it's actually the source code of strict type in the implementation describes and makes specification about itself. It's like strict typing reflecting all the strict typing. And it was, for me, it was a test case to make sure that the strict type are really complete when they are able to compile themselves and describe themselves. So this is a strict types library written in strict types. All the data types which participate them with no dependencies, so the whole data type system is here. And you see different sorts of data. Many of these data have clear distinction of the number of elements, for instance, like number of elements in the array. You have this strange naming, which comes from the fact that it is able to compile generics. So you can write a generic in Rust, arbitrary complexity with the constants and so on, and it will produce a separate type for each generic variant that is used in the code for real. And yeah, you see the type system. This is a binary form of this library, so you can import it into Alluvium and work and run the strict types in Alluvium itself. And it has this library ID, which is Mama Jamba Sinatra. It's just random. It's a vocabulary of mnemonics, and it takes the checksum and converts into mnemonics such that people, the moment I change something here, it changes this mnemonic and I can easily detect it. You can download this library, you can run it yourself. It's basically inside the test, you have the test called reflection. And that's what this reflection test produces, the description of the library itself. It compiles the library, it takes the builder, it processes the root type, which is type lib, and it compiles all the types that coming from Rust. And if you check how this looks like, for instance, we check the abstract syntax type, which is a complex enum. This one covering different type variants, enums, unions, and the only thing you need to make it strict type compatible is to add this derived directive. You don't write any other code, and it's compilable into strict types. So that's simple. When you use, you're also able to do import other libraries, so you can create multiple libraries, and these libraries will be depending on each other, and these dependencies are described with a special package manager called parcel. And here it looks like pretty much like Rust Cargo TOML, but instead of specifying version or repository, you specify actually the type library ID plus a mnemonic, such that you always see which version of type library you're using. And if you do a different version, it would have a different mnemonic. There is no like version 1, version 2, it's just a different IDs. And then you just import it here, and you may be sure that when you do this import, because it basically imports this library with this ID, you have a guarantees that no updates can happen. You can't download a new version of library and something breaks, because you basically commit to the semantical structure of the library itself. And with this 0.10, we have 3 main libraries. We are not writing them because it's basically we take the crates, Rust crates, compile with them with a strict encoding, strict type, and we are getting automatically strict type libraries. So we have a library for client-side validation primitives, like multi-protocol commitments described in LNPBP for standard for Bitcoin protocol, including blockchain level and single-use seals used in RGB, and for all RGB consensus level structures. And this compiled libraries is actually a formal specification of the memory layout and serialization for all RGB and Bitcoin data types as they used in RGB. Finally, you'll have in the future, we plan to do another interesting thing, that you can take a binary type library and generate the code in any language which will read this type or write this type, as it does today in Rust. So with that, we plan to add support for Swift, Kotlin, and TypeScript, which should be simplifying how different software can interact with RGB data, not even depending on RGB libraries, and still be sure that it parses the data in the same way as RGB consensus rules define. Also, different type libraries, if you have a multiple type libraries, they can be linked together into strict type system, a single binary, and packed into the package. And package takes this strict type system as developer certificate, signature, and everything all together. And these parcels would be things which you import into RGB node when you import type library or a new smart contract. They become part of the consignments which come into RGB node. So that's the whole story that happens with the strict types. The constructor story will be pretty much the same. It's just an extension. With the constructor, you would have more like methods, functions, and other stuff. And there is a tool chain. These tools are not done yet. We will work on them later this year, but basically there would be a command line tools, which will be a compiler for strict types, linker, code generator, package manager, and general tool, which does all this stuff. Basically, the library and functionality is there. The only thing we need is to do the command line interface. So that's all for strict types. If you are interested in details, we have a website. We have a specification about how the type system works, which types are out there, how the types are composed, what is the semantic of the language, the low level. You have also general information, so you are welcome to check this stricttypes.org website. It has links to create and standard and API docs. So, and also in GitHub we have this strict types organization. You're all welcome to contribute and study, and that's all on my side.
Cool, thank you. Should we go to questions? Giacomo, you have any questions?
No, I think it's clear. Very, very nice.
Anyone else? Okay. If there are no more questions,
maybe questions not related to strict types of presentation, but general questions about RGB or some pending development issues which we need to discuss in voice. Zoe, Federico, Hunter, Gideon, anybody?
Can you hear me?
Yeah.
Okay. So regarding something that you were covering before, like, could you explain again how the backup procedure will work in the 0.10?
So with the 0.10, the RGB becomes very similar to the way Git works, not GitHub, Git, the command line tool, because Git is it also works with the client-side data. It just don't commit them into blockchain. And I took this example and understood that you don't need to run a dedicated memory process all the time, because the only 2 points in time when you need to access the data is when you either do a transfer or receive a transfer. And you don't need a process that runs in the memory all the time when you don't do this stuff. So instead of having a full node on mobile, you would have a library which works with the file system, the same file system as in the node. And through this library, you directly read and write the data from the file system, the same way as Git does. So when you need to backup the data, you just backup the part of the file system. And you're sure that you are not accessing this data because you access the data from the wallet through the library, not through the process. And even if you would like to have a validation as a separate worker, as a separate thread, the wallet can easily detect that this thread is running or not, or stop this thread and do the backup. So this basically gives the tools to the wallet to separate backing up from all other tasks and be sure that when backup is performed, no other tasks are touching the same data directory.
Okay, thank you.
Does it explain, or if there are any questions, please ask. I will try to put in some other form.
No, it was clear enough. Clear enough.
It's like how you can back up your Git repository. Just do copy files from one directory to another. Run targ zip something.
Yeah, makes sense.
The RGB node would be required only when you would like to have something running constantly to receive incoming transfers. Of course, on mobile, it doesn't make sense anyway because you don't have a permanent IP address, so people can't send you incoming transfers. And the only thing where you need that is your home server or home desktop, which if it does have some permanent address, or your server or home box, something of that sort. And that's where you will have RGB node, which will be just a tiny wrapper around the library. All the validation will still be performed by the standard library, but the node will just listen on some network port, be ready to accept the incoming consignments from the Lightning network through the Lightning node, or through some RGB or RPC interfaces done by also you guys.
But I guess also mobile, you may want to have the wallet to constantly listen for a new consignment that may arrive at any point, because they say I need to pay you, but I will do it in 1 hour, and so you need the wallet.
But for this, you need to set up a server, and the server is not running on mobile. So you would still have an RGB node somewhere on the server, but not inside the mobile application.
No, but what I'm saying is that people may want to have this functionality without the server, so they may want the mobile application to run continuously to be able to.
But you can't, even today, you can't send directly to mobile. You send through the server of the wallet provider.
But with Storm, wouldn't that be different?
No, you can't open a port on mobile phone. Anyway, the operating system doesn't allow you to open a listening port. You have to do outgoing connection. And when you do the outgoing connection, you don't need a node. You do it right from your wallet. The only point where you need a node is when you're listening on some incoming connections, and there can't be any incoming connections on mobile phone.
That's it.
Is it at this point is cross any kind of platform, Android, Apple? This is just basically final fact, right? There is no way around it.
Yes, it's on all mobile platforms. They all prohibit you from opening a local port. And even if they allow that, you can't publish your IP address because it's variable and assigned by the mobile operator as you move through the city.
For example, if you have so can you run it in theory with something like Orbot, a Tor service on a mobile phone? In theory, yes. Like your public key remains the same, even if you switch process and you keep receiving data on that.
Well, in that case, you need support of the operating system because you also have to notify Tor network that your address is changing. So you need to do some sort of stuff each time you assign new IP address.
So if I move around with Orbot open, in theory, my secret will fall down when I change myself. I never tried that. Probably.
Well, today you can't do that. You need a special phone where you install something like modified version of Grafana, which you should program to notify you on mobile address changes.
Yeah, at that point I just use Andronix with Linux on mobile, and we are outside the mobile application scope. Okay.
Yeah. So maybe one day it become possible, but in realistic scenarios, probably we shouldn't address these cases in RGB at this stage, at least when there is real phones doing that.
Also, because I think the tendency was actually the trend was the other way around. It was restricted more and more in the last years.
Yes, unfortunately. Like with mobile, you don't have full access to the file system, to the process management, to the network connectivity, and the restrictions are more and more. So operating system now becomes kind of censor to what applications can do. It's very unlike comparing to, very unsimilar comparing to desktop. So I think the proper way of workaround around that is just to having home box, which has a Tor connectivity, and you use basically you listen on network from your mobile through that home box. So mobile connects to the home box, and home box does the home other part of the job.
Yeah, it's funny because this is a little bit off topic, but what I am playing around a little bit recently is Lightning nodes on Andronix on mobile. So you can have your box on mobile connected to your home network, but you have to completely overrun the operating system, basically, or create a open operating system within the Android platform.
Yeah. Andronix, actually, I never tried it. It's very interesting.
Yeah, try the, sorry for the off topic, guys. Try the Smartino. There's the repository called Smartino by Italian guy. And he already packaged Bitcoin Core and Electrum Electrus inside Andronix. And I tried on an old Android. It's way better than Raspberry Pi. Super silent, super cool in the temperatures, in thermodynamic sense. And it's very, very low consumption.
Interesting. And how long it takes to synchronize the blockchain, or there is some way how to?
I tried with the Wi-Fi, so it didn't really matter. But it was basically less than 5 days, which is better than my Raspberry Pi last time.
Mm-hmm. Interesting.
Giacomo, but is it like on your phone or some other device?
It's the phone. It's the phone. You can basically you have inside Android is a Linux emulator that will access enough of the phone resources to run Linux, and on top of that you open and you can even expose Electrus with the Tor address. You can basically do. Of course, it's an emulation, so you will have some resource degrading, but the end result is that you have this stuff which is better than Raspberry Pi, less heating, less noise. You need an external disk, of course, otherwise you need an SD card of with 2 tera, which is possible but super expensive at this point. It's not worth it. And so I just connected with an external SSD to the micro USB port. And it's so far it's very. I didn't try to put Lightning on top of it and join market, but I will eventually. And I think it's worse than a laptop, but way better than a Raspberry Pi.
Any more questions, guys? Maybe we can wrap this up then for today. It's been 1.5 hours, which is kind of our normal time. Thank you, Maxim, for the presentation and for explaining all the critical fixes and changes.
Thank you for listening.
Thank you guys for joining the call as well. And if you have any questions, you know where to find us. And see you in 2 weeks. Bye, guys.